describe a sequence of transformations that transforms the graph of arctan of x to the graph of arctan of 2x plus 1 plus pi over 4. There are two possible sequences of transformations, and the first sequence is, according to this plus 1, it's translation by a vector -1, 0, or it's just horizontal translation 1 unit to the left, followed by, according to this two, it's horizontal contraction by factor of 2 with y-axis invariant. It means that all points on y-axis remain on the same places, but all other points becomes 2 times closer to y-axis, and followed by translation by a vector 0 plus pi over 4, or just pi over 4. Or horizontal contraction, we can say horizontal stretch by factor 1 over 2. Or the second possible sequence of transformations is, if we make parentheses, when we factor out 2, we get arctan 2x plus a half plus pi over 4. And then we start with this 2, so it's horizontal contraction by factor of 2 with y-axis invariant, or it's the same as horizontal stretch by factor of half, and followed by horizontal translation 1 over 2 units to the left, or just translation by -1/2, 0, and followed by translation by 0 pi over 4. And you can notice that here we can apply one transformation. It's translation -1/2 and pi over 4. It's possible here, but here it's not possible. If you write translation by -1/2 and pi over 4 followed by horizontal contraction, it will be not correct. And the next question shows that arctan P plus arctan Q is equal to arctan over P plus Q over 1 minus P multiplied by Q. And we remember that always when we meet the sum of arctangents, we can apply this formula to simplify it. This formula is given in a data booklet. So let's consider tangent of the left hand side. So tangent of arctan P plus arctan Q, and according to this formula it becomes tangent of arctangent is just P plus just Q and divided by minus 1 minus tangent, so it's tangent of arctangent P, just P and Q, and we can see that it is equal to tangent of the right hand side, hence it's true. The next verifies that arctangent is equal to arctangent plus pi over 4, and definitely we should use the result from B, but there must be the sum of arctangents, and we know that pi over 4 is arctangent of 1, so if we consider the right hand side, it becomes arctangent over x plus 1 plus arctangent of 1, and we can apply this identity, hence this sum becomes arctan of the sum, so it's x plus 1 plus 1 minus the product, it's just x plus 1 multiplied by 1, and let multiply each term by x plus 1 and get, it becomes just x plus 1, x plus 1 minus x, and we can see that it's just arctan of 2x plus 1, and we can see that it's the left hand side, so it's true. And D. Use mathematical induction and result from B to prove that the sum is equal to arctangent of n over n plus 1. So the first step is, as usual, we consider the first possible value of n, it's 1, so for n is 1, the left hand side becomes sum for r from 1 to 1 arctan of 1 over 2r squared, and we can see that there is only one term, so r is 1, so we consider arctan 1 over 2, and it's the left hand side, and let's consider the right hand side, it becomes arctan of 1 over 1 plus 1, so it's arctan over half. So as the left hand side is equal to the right hand side, true for n is 1. The next step is, as usual, we write assume true for n equals k. Assume true for n equals k, and just rewrite this statement substituting k for n, so it becomes sum for r from 1 to k arctan of 1 over 2r squared is equal to arctan of k plus 1, and then we consider n is k plus 1, so we write for n is k plus 1, the left hand side becomes the sum from 1 to k plus 1 arctan 1 over 2r squared, and sum up to k plus 1 can be represented as sum to k plus a term corresponding to k plus 1, so arctan 1, and term corresponding to k plus 1, we just substitute k plus 1 for r, so it becomes arctan 1 over 2 k plus 1 squared. And we can substitute this result for the sum up to k, so it becomes arctan k over k plus 1 plus arctan 1 over 2 k plus 1 squared, and is equal to, and we can see that there is the sum of two arctangents, and we can apply this result. So the sum of two arctangents is equal to arctan of the sum in the numerator, so it becomes k over k plus 1 plus 1 over 2 k plus 1 squared divided by 1 minus the product, 1 minus k plus 1 multiplied by 1 over 2 k plus 1 squared. And let's simplify it, arctan, and we can multiply each term by 2 k plus 1 cubed, so it becomes 2 k plus 1 squared plus k plus 1 divided by 2 k plus 1 cubed minus k. And let's consider what should we get. We should get that it is equal, this must be equal to k plus 1 divided by k plus 1 plus 1, so over k plus 2. So this must be equal to k plus 1 over k plus 2. But we can see that there are polynomials of degree of 3 in numerator and denominator. So we can see that since there is plus minus, we cannot simplify it, but let's open parentheses to get directly two polynomials in numerator and denominator. Arctan of it's k squared multiplied by 2k, it becomes 2k cubed plus 2k multiplied by 2k plus 4k squared plus 1 multiplied by 2k plus 2k plus k plus 1. And here it's you may apply binomial formula a plus b cubed, so it becomes k cubed multiplied by 2k cubed plus formula a plus b cubed, it's a cubed plus 3a squared b plus 3ab squared plus b cubed. So it becomes k cubed multiplied by this 2 plus 3k squared multiplied by 2 plus 6k squared plus 3k multiplied by 2 plus 6k and plus 1 multiplied by 2 plus 2 minus k. And it is equal to arctan 2k cubed plus 4k squared plus 3k plus 1. and denominator becomes 2k cubed plus 6k squared plus 5k plus 2. And we should get that it's arctan of k plus 1 over k plus 2. And how to get this? Since we need k plus 1 in the numerator, idea is the next arctan, and definitely it must be true. So idea is the next, since we need k plus 1, so let's try to rewrite it as k plus 1 multiplied by something. And how to get this another polynomial? So let's just divide this polynomial of degree of 3 by k plus 1. So we write, let's apply synthetic division, we write -1 and coefficients 2, 4, 3, 1. Since it's a polynomial of degree of 3, there must be 4 coefficients, empty, 2 multiplied by -1, it's -2, the sum, it's 2, again 2 multiplied by -1, -2, and it's 1, -1, 0. We get 0 here, and it's the remainder. So k plus 1 is a factor, and -1 is the root of this polynomial. Hence, this polynomial becomes k plus 1 multiplied by 2k squared plus 2k plus 1. And do the same with the denominator, since we need what? K plus 2. So let's try to rewrite it as k plus 2 multiplied by something. So again, divide by k plus 2, so we write -2, coefficients, it's 2, 6, 5, 2, and empty, 2 multiplied by -2, it's -4, 2 multiplied by -2, it's -4, sum, it's 1, -2, 0, remainder is 0, so -2 is a root, k plus 2 is a factor, so this polynomial becomes 2k squared plus 2k plus 1, and we can see that it cancels and we get what we need. So we get arctan k plus 1 divided by k plus 2. Hence true for n equals k plus 1. And actually there may be another way to solve this. If you need k plus 1 over k plus 2, you can here, if you need k plus 1 in numerator, you can multiply numerator and denominator by k plus 1, and if you need denominator, if you need k plus 2 to be in the denominator, you multiply numerator and denominator by k plus 2, and then you multiply k plus 2 by this polynomial and multiply k plus 1 by this polynomial, and you get that k plus 1 over k plus 2 multiplied by something here, and you get equal results here, or this remainder, these terms will cancel, they will be equal. It's not useful here, but in general it's possible. So as a possibility to solve such problems, if you need something, you may multiply numerator and denominator by what you need, and then simplify all remainder terms. And conclusion. If true for n equals k, true for n equals k plus 1. Since true for n is 1, true for any n, true for any n is positive integer. And that's all for this question.